Good morning, everybody. Thank you for joining us here today. We'll be hearing from the Akora Resources Managing Director, Mr. Paul Bibby. We'll be talking to us about the recent results from the Southern Zone at the Bekisopa iron ore project. This project's looking better and better at every return of results. I'll hand it across to Paul and we'll have some questions at the end. Thanks, Paul.
Terrific. Thank you, Peter, and good morning, everybody. And again, thank you for joining in to hear about the Bekisopa project updated as part of the Akora Resources suite of projects in Madagascar. Today's cover photo is what really attracted us to Bekisopa. This is lumps of iron ore near one of the pits that was dug in the 60s, and these rocks here grade 66% iron, and this is what attracted us to go and do the work that we've been doing and reporting on over the last 18 months. And what we're now seeing from the drilling results, and today we're going to focus on the Southern Zone, is that we're more confident of a DSO startup and a high-grade iron product future at Bekisopa. I think we all understand the forward-looking and competent person statements, so thank you for having a quick read of that. As we've said before, Bekisopa is in south-central Madagascar. The port of Toliara, which is an operating port, is on the southwest coast, but also the coastal town of Marumbe, which is directly some 200 kilometres or so directly west of Bekisopa, is potentially also a port that we could be shipping product from a future operation at Bekisopa. At Bekisopa, we're now seeing it to be a low-cost DSO startup operation, focusing on the high-grade outcrop, the image on the top left-hand corner, outcrops from the rock chip samples we've done, grading 66.7% iron, and also from the zone where we're seeing very high grades. In this case here, Bekisopa number 17 in the south, 66% iron in that weathered zone, which would produce both lump and fines product going forward. The Bekisopa drilling campaign is completed. We've completed 63 drill holes for some 6,200 metres drilled. The image on the right-hand side there shows you the strike length north to south on the main tenements of Bekisopa. The green dots, the locations of the drill holes there along the whole 5 kilometres of that main tenement. The drilling has confirmed without doubt that the mineralisation continues below the high-grade outcrop, which is the first thing we wanted to prove. It's at depths to at least 300 metres down dip, as we've shown in the northern zone, and along the 6 kilometre strike, with widths across strike of 750 metres in the south. You can see quite a significant drill grid there in the south, widths of 750 metres there across strike, and true thicknesses down dip of 50 to 170 metres. So quite significant continuous iron formations at depth. Remember, we've also only drilled 30% of this 6 kilometre strike, so there's quite a few gaps there where we haven't drilled at all. And the results that we get for the JORC resource are going to come from this drilling. So there's potential for a significant iron ore body along the 5 kilometre strike. And when you consider we only drilled 30% of the strike, it's going to be quite a significant JORC resource potential at Bekisopa going forward. I should also add that these outcomes are just on the main tenement, 10430. There's still drilling to be done in the tenement to the north, 3757, as you can see on the image there on the right. But also we have tenements to the southwest, some 10 kilometres away, which also has a strong magnetic anomaly and some interesting iron outcrops as well, which we need to do work on. So focusing today on Bekisopa South, the Southern Zone. So we've reported already on the northern and central zones, and the image on the right, the magnetic intensity, you know, the strong reds and oranges there is where the iron ore is outcropping and close to surface. And today we're reporting on the Southern Zone where there's quite a significant drill grid there for 37 drill holes. And if you look right at the bottom, there's a red magnetic sort of node or intensity area with 2 drill holes there at the very south of the Southern Zone. So widths of 750 metres across, north-south of 1,000 metres. What we're seeing from these 37 drill holes, most of them are shallow, less than 100 metres, and 11 have been from 115 to 208 metres, is that we have an iron formation that is flat-lying to depths of 179 metres down hole. quite significant widths, significant true thicknesses of continuous mineralization up to 170 meters, as you'll see in the cross sections. And as you can see from that drill grid, it continues 1,000 meters along strike north-south and potentially 1,500 meters from the very south to where it joins in with what we're calling the central zone. So quite a significant ore body has been proved up from all of this drilling now. So looking at the cross sections in the southern zone, this is drill line 1. And what we see here in that sort of pinky light brown color is a flat lying iron formation from east to west over 750 meters, open at surface on the east and the west, and ideal for a low stripping ratio DSO startup. And we're seeing high grade iron ore intervals and readings at surface from 60 to 65%. If we start at the top left-hand side there of the image, you can see 65.5% iron, 63.4, 64.5, 63.6 at depth, quite a significant intercept there, 63.6 at surface, 65.4 at surface, all suitable for direct ship iron ore, lump and fines product, truck, crush, screen, and ship them out as lump and fines product, grading, as we can see there, sort of 60 to 65% iron ore as part of the DSO startup. Looking at drill line number 3 in the southern zone, similarly, a very large flat-lying ore body, open at surface on the east from drill hole 17 through to drill hole almost 46. Some high-grade results there of 66% iron and 63.7% iron. So that will be selected as part of the DSO startup. And then significant intervals. If you look at drill hole number 47, an 80-meter interval, 46, 171 meter interval at 35% iron, and the like. So quite a significant ore body. And we've shown from the product trials that that type grade of material, 27 and 35% iron, readily upgrades at a 2 millimeter crush to produce better than benchmark grade iron ore fines. So some significant iron formation intercepts there and cross sections in the southern zone. As before, we've done product grade trials on continuous intervals from surface to depth. In the southern zone, we've done 2 trials, one on the east and one on the west, to confirm consistency across this quite wide 750 meter by 1,000 meter zone. And what we've found is that the WLIMS trials have upgraded to better than benchmark grade of 62.4% on drill hole number 10. You can see on the composites on the left-hand side, surface to 5.6 meters there is potentially DSO. And even the composite number 7 at 33 to 37 meters below surface, which is massive iron, grading 58.5%. There are companies that are shipping that and lower grade iron as DSO today. So there's potential there for quite a bit of DSO in this area in the southern zone. But we're looking here at the product grade trials and how readily this average head grade of 47.9% upgrades at a 2 millimeter crush using magnetic separation. And we've got a 62.4% average grade, low silica and alumina, both in spec, and low phosphorus and sulfur at good recoveries of iron and mass yields at 65%. For drill hole number 34 on the western side of the extensive southern zone, the WLIMS 2 millimeter crush upgraded an average head grade of 53% to 66% iron. A premium high grade product, low silica and low alumina, as you see on the bottom right hand side of the table, 66% iron, 1.9 silica, 0.8 alumina, and 0.8 phos and 0.1 sulfur at a 96% iron recovery and a 78% mass yield. So very good numbers. And looking at the composites there, we've got a mixture of weathered massive iron at the surface and certainly some massive iron down there, grading 60% to 45 to 60% at 35 meters downhole. So again, we've shown the consistency of the Bekisopa iron up to 2 millimeter crush, whether it's in the north central or this expansive southern zone, to certainly better than benchmark grade of 62%, but also more likely around 65% on average. We've also done some Davis tube tests here on the two composites, Bekisopa 10 and 34. This material has readily upgraded to 69.3% iron. So again, consistent results at a 75 micron sizing to 69.3% iron and very clean, lower impurity levels, matching what we've seen elsewhere along the 5 kilometre strike at Bekisopa. Similarly, the product trials and Davis tube tests at 75 microns and drill hole 34 from the western side has shown an even better result of 69.5% iron. So very consistent, premium, high-grade iron ore products from Bekisopa, either at a 2 millimetre crush or a 75 micron size. And down the track, I'll probably look to do some trials at 100 microns. And my guess is we'll see very similar high iron results at even a coarser size than 75 microns. Just looking at these results graphically, the surface to 37 meters on drill hole number 10 and then on 34 has upgraded to very high grade WLIMS results in the southern zone, an average grade of 64.2%, so better than benchmark grade of 62, which is getting a very good price these days. We expect comparable results across the expansive southern zone. And the pleasing thing that, now that we've got all the results from the north, central and southern zone is the consistency of that we've been able to see. Crushing to 2 millimeters has produced an average grade of 64% from all of these WLIMS trials along the 5 kilometre strike, whether that's in the north, central and now the southern zones. So very good, consistent high grade results at a 2 millimetre crush. Davis tube tests in Bekisopa South, better than 69% iron at 75 microns. We expect comparable results right across the southern zone. And the average grade now that we're seeing in the north, central and southern zones at a 75 micron sizing and magnetic separation is 69.8%, which is a extremely high quality iron ore product suitable for direct reduced iron pellet feed. Graphically, we've shown these ones before. You can see the head grade here in iron readily increasing in grade at a 2 millimetre crush and then at a 75 micron sizing. More than likely, those top 3 or 4 composites from 10 and 34 drill holes will be DSO, so they won't even need to be crushed to produce a product. They'll be saleable in lump and fines just from direct mining and crushing and screening of that. But the others, head grades of 40% towards 57%, readily upgrade to better than benchmark, and 70% at 75 microns. Similarly, the impurity levels, whether it's silica or alumina or phosphorus or sulfur, all the others have reduced dramatically as we upgrade the product at the different magnetic separation trials that we've conducted. So what we're anticipating now that we've brought all of this information together over the last 12 to 15 months since listing and the 6,200 meters of drilling that we've done on the Bekisopa main tenement is we anticipate a high-grade DSO startup at Bekisopa. It's high grade because we'd be focusing on the outcrop, which we know grades 66% iron on average from the rock chips, and then by crushing and screening the very high grade surface weathered zone, where we're seeing grades from 64% to 68.5% in these drill core samples from the southern zone, Bekisopa 31, and I think that's 16 under there. So years 1 to 10 produce high-grade DSO plus 65% iron, lump and fines from the outcrop and the very high-grade surface zone. This is achievable in the north, central, and today we've shown how it's readily achievable in the southern zone, in quite the very extensive southern zone. And then as we've moved through the first 10 years of operation of DSO, which we know is a low capital and operating cost startup, we'd look to produce iron ore fines at a 2 millimetre crush size using dry magnetic separation. We've used wet magnetic separation in the lab because that's the best way to do it in the lab scale work. But dry magnetic separation is becoming the norm now We're seeing companies like Vale and others using dry magnetic separation to produce their fines products. And we'd look to upgrade the weathered surface zones that isn't DSO capable, although this Bekisopa 9 more than likely is. But at depths, we're seeing grades of 30 to 55% iron. These will readily upgrade at a 2 millimeter crush and magnetic separation to produce 65% iron fines, a high grade fines product, and 62% benchmark grade fines at depths, as we see at the southern zone and also along all the zones at Bekisopa. And then as the steel industry moves to decarbonise to improve its carbon emissions, they will move to using more natural gas and hydrogen. They'll require a very high grade feed material, forecast to be better than 67% iron to make the DRI pellets to feed those electric arc furnaces and the Midrex furnaces and the like, and with extremely low impurities. And we've shown that on the material in the southern zone, Bekisopa 10 and 34, we're achieving 69% iron. And even if we go down and do some tests on 15 to 25% iron grades, we're achieving an average product grade of 68% iron at a 70 micron crush, which is better than the 67% required for DRI pellets. So very encouraging opportunity for the mix of grades that we're seeing across the Bekisopa main strike. Not just 68% iron from a 15 to 25% head grade, but low silica, alumina, 008 phos, and 017 sulfur, all very suitable for that future opportunity, which is going to be sought after and I believe demand a high price for this high quality product. So in summary, Bekisopa South is a significant iron formation. The iron mineralization is a high grade DSO at surface. We've seen those results of 60 to 65% from the cross sections. It's a flat lying iron formation, ideal for a low strip ratio open pit. It's been confirmed over 1,000 meters in that grid, north to south, and widths of up to 750 meters, with some true thicknesses extending up to 170 meters of continuous iron mineralization. So the southern zone is now proving to be part of a substantial iron resource along a 5,000 meter length on the main strike at Bekisopa. So in summary, looking at the product grades, initially a DSO, 64% iron or better from across the full north, central and southern zones on the main strike length. And then as you move into the lower head grade materials, the plus 30%, 25% irons, they upgrade at a 2 millimeter crush to produce a 64% high grade fines product after magnetic separation, again with low impurities. And then as the demand grows for green steel future, producing better than a 67% iron product, we've demonstrated that the Bekisopa South southern zone produces 69.4% iron, a premium high grade sought after product, low silica and alumina, phosphorus and sulfur. So thank you very much for your time. And it's probably just worth noting that the iron ore price in the first week of March for 62% benchmark is averaging in the first week at about 148. 65% iron at $30 US higher at 177 US dollars per tonne. I think there's a really good opportunity for Bekisopa to be a high margin producer from that DSO startup and also through the future opportunities as we produce the other products for the iron and steel industry. So thank you very much for your time. And Peter, I'm happy to take some questions.
Thanks, Paul. Another really good summary, and for shareholders to explain actually what is going on and understanding exactly what you're seeing. It's a great opportunity for you to be able to talk directly. The commodity price environment now is looking very optimistic, and we had some pretty good runs in base metals with nickel up 60% overnight. Iron ore prices have recovered to pre-Ukraine price levels as well. The outlook is pretty solid at the moment. Does this disruption around the world bode well for iron ore pricing as well?
Oh, look, who knows? Who knows, Peter? Look, I think we're seeing very strong prices now. And for Bekisopa, if these prices were to continue for the next number of years, we're in a very good position to have a high margin, DSO startup. The volatility in the Ukraine, which is very, very unfortunate, is going to disrupt the supply of iron ore to the world. Ukraine is a fairly major producer, as is Russia. So there's going to be a lot of catch up when that war is over. And therefore, I think the demand supply will be out of balance for a while and will maintain these very attractive prices going forward, you would think. So look, who really knows? But as I've said before, these are fabulous prices. The work that we do when we get into the study phase, which will be starting post the resource being reported, we won't be using these prices as our reference point for our studies. We'll be using a long-term average price, which is more like $100 to $110 per tonne for benchmark grade.
Paul, it seems that there are a lot of attributes to this this project, but two that stand out for me are the friability or the crushability of the material, yes, and the low level of impurities. That really seems to be make it stand out.
Very much so. For similar deposits around the world, we're not seeing this outcrop high-grade material or the weathered zone to the extent we are seeing at Bekisopa. But of most important is the ability at a 2 millimetre crush to produce better than benchmark grade, even to produce 65% iron grade in a large proportion of the iron formation that we're seeing across the 5 kilometre strike. So the mineral size at Bekisopa is coarser than you would typically see, and therefore the ability to produce a product at a 2 millimetre crush is very attractive. And even if you want to upgrade that to better than 67% for DRI pellets, we've used assay pulps, 75 micron material, and we're achieving that. Similar projects around the world in operation today or looking to be in operation in the future, they're grinding to 15, 25, 40 microns, which is a lot more capital and a lot more operating cost expense than we'd ever expect to see at Bekisopa at a very coarse size of 75 microns to 100 microns down the track, when that demand for that sort of product is going to be increasing.
Paul, is there much difference in costing for the process going from 75 microns, from 100 microns to 75 microns? Is it much of a difference or is it marginal?
I think it's going to be quite significant. Look, I haven't looked at the capital and operating cost for that scenario, but to get to 100 microns, you'll need less equipment and less time in the process. So therefore, the operating and capital costs have to be significantly different. So it won't be a marginal thing. It'll be quite a noticeable difference in the costs.
And in the processing, do you see the path forward as dry limbs or wet limbs or other?
Look, I've already started talking to people about dry magnetic separation. Here in Australia, we've got some excellent technology, which is being proven up. But we're seeing in Vale, with the issues that they had a few years ago with their tailings dams, the result of using wet limbs and significant amount of tails over the years, that has a number of costs and issues associated with it. But they're now transferring and spending significant money updating their processing technology to dry magnetic separation. So it's proven, it's available, and that is what we would look to do at Bekisopa, because it eliminates the need for a large amount of water. Not that water's an issue in Bekisopa, as you know, because we can't get there for 3 or 4 months of the year because of the wet season and the nearby river, but also the requirements downstream in terms of the tailings, and that they all go away.
And Paul, we're looking forward to the resource. How's that work going?
No, very busy. No, it's been a busy start to the year for us at Akora, getting out the drilling results from last year, North Central, now the Southern Zone. The resource geologist is well underway, is completing the work on the Northern and Central Zone results, and has ironing out all of the issues and better understanding the resource characteristics using the North and Central numbers, and we'll be starting on the Southern Zone this week. The resource geologist knows that I want these results out by the 17th or 18th of March, and I plan to report on them at the Brisbane Mining Conference on the 24th of March, at which the resource geologist will be attending. So he understands the deadlines and is working very hard with us to achieve the delivery of the JORC resource for Akora at Bekisopa in the next sort of 10 plus days.
That's great. Thanks, Paul. We'll look forward to that. And thank you for your report here this morning. And thanks for everybody joining in. We look forward to hearing the good news in the near future.
Thank you very much, Peter. And thank you to everyone who's been listening in. Appreciate the support. Thank you.